one thing to guard against definitely will be to regularly update the data tables this looks into, and if possible, actually maybe link them directly to sources like the Athena Institute, so that should this model, you don't want versions to be released where someone 2 years from now uses the same multipliers that are no longer applicable.
One thing
Sorry, go ahead.
One thing I haven't grasped is how detailed the description could be of the heating systems in these buildings. So let me put it this way. I think that in very few cases, if any at all, will someone say, I will not build a new house, but keep the old one because I've run this model and I see how much better it is for the world. I think what is much more likely to be the case is this could become an instrument that informs policy. So when you're able to demonstrate how much more or how significant the embodied energy component is compared to the operating energy curves for existing buildings, for some improvements rather than no improvement, or some improvements rather than other improvements, it can be a very powerful tool for people and could keep some buildings from getting wrecked, left standing, but disfigured. And I think in order to do that, we would need to be able to differentiate between you're having an oil-burning furnace, an uninsulated building, storm windows on the outside, that kind of thing for the existing building.
So perhaps, Henry, if we were to do the same sort of drop-down menus on the right-hand side where we get into more granular detail about the operational efficiencies, kind of like, we have these inputs for embodied energy for the demolition and reconstruction, but right now we're sort of relying upon an efficiency multiplier one way or the other. Do you think it might be better if we had the ability to kind of define that in a more comprehensive sense?
I think so, but I could be dissuaded because what we're trying to do is imagine whether at the point when you would renovate the old building or build the new one, you would, I assume, put the same quality of boiler and furnace and water heater into each of them. And their deterioration rates in terms of efficiency would still be the same.
That would make sense. I'm looking at, the 65 Pleasant Street would be, in addition to its necessary structural rehabilitation we have to do, looking at systems upgrades, should we take it that far? I think we would definitely look at things like tankless and passive solar hot water and things you might do if you were to build an entirely new building. One point in favor, and this, this model can't really control for it, but really an actual issue with 65, and it was facing demolition because if another developer had purchased it and it actually got through demolition delay, which is doubtful but possible, that they would have put up a larger building because it's a 10,000 square foot lot. So really, it's tough to say that, we could model that, I suppose, like what would happen. It would be more of an energy consumer, and maybe that would make it less apples to apples. But it's just something to think about. We're focused on this idea of dealing with one of these buildings that has fallen in significant disrepair and making the investment, which is frankly rarely economically make any sense at all.
Right.
But in this case may make some environmental sense.
Well, the distinction I'm making is, I may be off base, but I think what's the powerful thing that you've done is you've created the ability to compare different kinds of changes to the same building. And I think that is potentially much more significant than the polemic that you might hope is buried in here about the contrast between saving an old building versus building a new one.
Yeah, I think from a practical perspective, that's extremely helpful. If you think about properties in Boston as they go through the demolition delay process, sometimes we don't have at that stage full information about exactly what's being proposed for replacement or even exactly what the existing, all of the information about the existing building. But what this allows you to do is to put in, a number of options and to say, even if, say that, the building that's proposed, if there's sort of a range of options for what it might be, you could still, compare a couple of different options to the existing, or you could, try out a couple of different assumptions about the existing building if you don't have the full information, and still make your case. Because the one thing that I keep thinking about is the fact that sometimes in in these situations when there's not a lot of time and you don't have full information, it can be a bit daunting. But I think what you can do is just, try. You can run it a couple of different ways and.
Yeah, it was definitely that was the idea. We could generate multiple iterations of the same thing,
Right.
and certainly, it's an assumption-based tool, particularly when you're talking about the idea of replacing it with something. Everybody knows that something is. We can say it's comparably sized. In the model you're looking at here, the green building I chose, and it's not fair again because it didn't have actual specs, but it was based with structurally insulated panels, which have wonderful R value and are quick to put up, but they also have pretty serious carbon consequence. Additionally, I'm not too sure where my SIPs are. I'll find them. My wall.
I don't mean a new model, but to fill it in for another building.
Yeah, good question.
Is this a $5,000 event? Or?
Henry, can you repeat that for Sophie?
Yeah, Sophie, how many hours, now that you're familiar with the system, and I heard you say I-22, I mean, that's familiar. What I wonder is how much time it would take you to enter another building into
to enter the numbers for the building?
Yep. Is it 2 days' work?
Oh, I mean, it just depends on what information you have available. So maybe Mike would be even more qualified to answer that question because he's the one who went through and entered these numbers for 65 Pleasant Street. But if you have the numbers available, it would take you less than an hour. If you don't have the numbers available, it could take a lot longer.
And I'm a bad example because bungling through, but if we had takeoffs, and that's kind of the goal, like I knew how many lineal feet of wall section, and I knew the general composition of what it was, and that input was loaded into the model already, and in a new construction most certainly is. On the preservation case, not quite yet. But it's really quite quick. You can model anything within an hour or two. The level that this model takes it to make it more detailed and to expand on the operational distinctions like you were talking about, or for that matter, to get into more degrees of again, just detail.
So it's really the quantity
longer,
survey.
It was meant to be kind of a quick analysis tool.
So it's getting the quantities, really, and making.
Yeah, it's all quantity driven. The drop downs have all the lookup tables that are behind this model you can find. It's actually a much larger spreadsheet than it looks like. Sophie just hit all the information to make it as sort of user-friendly as possible. But really, if you just have the quantity takeoffs and you believe in the numbers that the Athena Institute is providing you, then the model does its job very efficiently, and it arrives at that carbon consequence, within, as fast as you can input it, basically. If there aren't any more questions, I know that it's 3:15, and this is a run-through, and we sincerely appreciate everyone taking the time to sort of hear this initial attempt. If you wouldn't mind, if you had any thoughts you can memorialize by email, it would be sincerely appreciated. I don't think that this effort is going to end here. It's about sort of figuring out what to do with it next and how best to implement it, because there is some wonderful work that the team has put into this. And again, while it's not certainly a silver bullet, it is a more informed way of looking at that critical decision environmentally of saving a building or demolishing it and building new.